Okay. So we are going to talk to you about the software factors in smartphone obsolescence, and we are working on that for less than a year now. And in particular, the Observatory of Mobile Application Obsolescence. So we are going to see a little bit of definition of context, then a little bit of legal context, the presentation of our project, and the first results. So first, what is obsolescence? Well, by definition, it is a fact of being or becoming outdated, depreciated, and it concerns machines and processes. There are a few types of obsolescence. The first one is the psychological obsolescence. It is a desirability for a product. It is the fact that you have the iPhone 15 in your hands, and next year, you're going to have the new iPhone 16 and you want it because it is beautiful, it is new tech. You want it and yours feels old. Then you have the technical obsolescence with the material part. It is the fact that your phone has a broken screen and you can't use it anymore. You have the function obsolescence. It is the fact that your phone needs more and more resources over time to do the same task until it becomes obsolete. And you have the quality obsolescence. It is things that we put in your phone through updates, for example, that bring slowness or bugs. Okay, but why are we talking about that today? Well, when you have your phone in your hands, the most part of your ecological impact is behind you. It was during the construction process. It needs a lot of mineral resources actually to make phone. And I'm not going to talk to you about the planetary boundaries that you already know, the 6th IPCC report or the carbon impact. I am more going to talk to you about the work of David Maenda-Kitoko, which talks about the human sacrifices. He is a Democratic Republic of Congo refugee and an environmental activist that who talk about the metal extraction actually and the cobalt mine in particular, the war that is going there, the child labor, the rapes, the population driven from their home, the genocide. So there are also a lot of human impact actually. And with all that, we need to consume less. We can't use our phone just for 2 or 3 years in average, but for a lot more years. And in order to do that, we need data in order to legiferate, but we don't have any data on this subject. So that's why we're here. So I talk about the legislation. Well, we're going to see how it works. I'm going to take the example of Europe because it is well advanced on this subject. Well, one of the first laws that has been voted was in 2005 with the unfair commercial practices. Those are practices that are unfair, misleading, or aggressive, and that are going to alter the buying behavior of consumers. When you have this law voted in the Europe, you have then, you can see in pink, the law applied in at the national scale, with, for example, in France, the AGEC law. It is the anti-waste for a circular economy that protect consumers. For example, the consumer must be informed on the logiciel he is buying or on the update after that, or he has the right to repair his devices. And related to that, you have the association that led a legal fight against the industry. For example, in Orange, you have HOP, which is an association Stop Planned Obsolescence that is fighting Apple in 2020. Well, there are a lot of laws. I'm not going to talk about that today. It is very chaotic, but the thing that you have to understand, it is to make a law, you have a fight between the lobbies, for example, Apple or Samsung, and the collective. And in the collective, you have movements, like, for example, the right to repair in Europe, and associations like HOP. Well, now that we understand how it works, we can focus on a subject today. When you ask people what are the issues that they encounter with their phone, one of the first thing is the software part of their phone and the fact that they can't use their application anymore because their phone is too old, so they can't do their updates or they can't download the application like you can see on the screenshots. So we can ask ourselves how and how quickly do applications become unusable on older phones? Well, what we want to do is to observe and understand the obsolescence. In order to do that, we do data scraping in the app stores. We have the Android stores with the Google Play Store and F-Droid. F-Droid is a free and open source application store and software repository for Android with some restrictions to publish an application, like the fact that we can't use the Google services on those applications. And we will work on Apple later. The data that we want to retrieve in order to determine the obsolescence is, for example, the category of the application, like finance, travel, or game, and the minimal SD card version, which is a minimal API level on which the application is able to run. For our first graph, you have the latest security updates, dates, and you have the category of the application with the number of applications in each category. And we can see, this is on the Google Play Store, sorry. You can see that there are some categories better than others, like for example, game, which is the most backward compatible category with 75% of applications that are compatible with devices last updated in 2019. So this is quite good. And in the opposite side, you have, for example, the travel category, when you have 50% of the applications that are only running on OS version from 2021 or later. And you have also the finance category that is quite bad. But if your favorite game like Angry Bird doesn't run on your phone anymore, you won't change your phone for that. But if, I don't know, like Google Maps or your bank application doesn't work anymore, then you are going to change your phone. So yeah, it's very complicated that those applications are the worst. But this is not out of the extraordinary for first results. It is a longitudinal survey. We want to gather a lot more of data and more application. For now, the sample is quite little. We don't have a lot of historical. As you can see, we have 570 applications with no historical, just only one app version, 151 with 2 app versions, and 3 with 3 app versions. So the goal is to continue that, to capture app updates and to observe those obsolescence dynamics. For the second graph, we are looking at F-Droid. So you have the app release per years in gray. So we can see that now the open source application development is thriving. We have a lot of application now. You have the compatibility period per year. And we have stabilization, sorry, of 9 years of compatibility period those last years. And we don't have a lot of applications that last more than 10 years. We are looking at all the application of the F-Droid and not a little sample like before. So the goal of all that is to continue building our observatory. We want to render those data publicly accessible by a web interface. We also want to do static analysis. by looking at the dependence tree, the system call, or even the permissions. We want to do some dynamic analysis after that too, with the application size once installed on the phone, the footprint of the RAM and CPU, and the loading time, for example. And we want to do meeting with development team in order to understand their motivation for the upgrade and just how it works on the industry. If you want to conclude.
Sure. Thanks a lot, Gaelle, for this talk. And yeah, so I'm just going to phrase some open questions that we are thinking about. You know, because we are in a workshop, and so we are asking you, you know, please help us. So yeah, we want to understand what, how software, you know, becomes obsolete, why you can't use it on phones. So we'd like to understand the link between software engineering and obsolescence, and the end goal is to have the smartphone for 50 years. So what questions we may ask you is like, which metrics should we observe to understand obsolescence of software? I guess that you, some of you, most of you are more knowledgeable than us on what creates a bug or what creates a default, why this software doesn't run anymore. So what information are we going to gather from these metrics and stuff? Then what are the causes, what are decisions that cause the loss of a compatibility? You know, sometimes you say, let's bump the min SDK version. And when you do that, you're leaving behind a lot of smartphones if you do so, or on a computer too. So why would you do, what are the decisions that are taken that cause the loss of compatibility? And last, what are the quick wins? How can we just like try and raise the compatibility period of an application from 10 to 20 years, like in 2 years? That would be good. That would be a quick win. Thank you a lot.
I don't know if you have any question. I have some references too. Yeah.
Maybe you don't want to say that now, but because people want, what are your assumptions why this happens?
Oh, well, first thing is the security issue, because we have to patch up the fact that there are issuing application like your bank account must have the last API version if you want to not have intruders in it. So it is kind of complicated because you have to manage your choice between sustainability and security. It is our first guess, yeah. I don't know if you want to add something.
Yeah, then there is the trendiness of new features, but you know, it's really lesser. The duality between security and sustainability is really a big problem, because you know, I have a colleague, Clémentine Maurice back home, whose career is about taking the last Intel spec and breaking it. So every day, you know, she breaks a new spec, and so it motivates the creation of a new Intel processor. And so yeah, how are we going to reconcile sustainability and security? I don't know. Yeah, so open question.
And you have also the fact that in the development team, you want to play with new technologies. So as a developer, you're like, oh, this is new. You have a new library. I want to use it. I want to try. I like it. I love new technology. So this is an issue too. Yeah.
Also, because you're basing this on SDKs, right?
Mm-hmm.
So should you be looking at the difference between SDK releases? Like, because you said, you know, like new features. Sometimes features are there just because, you know, somebody had it on their problem board. Yeah. Sometimes there are important features that developers go in and because the developers ask for them. And that's why they migrate now not the SDK, because they actually ask for that.
Yes, this is the first result. This is just first tries to look at obsolescence. But yes, we will look at that to the goal. Yeah.
Sorry, I'm not sure I got it. So you say the difference between SDK and like the functionality embedded in the SDK?
Yeah.
Yeah, like break it open, the SDK, and look at the features inside.
Yeah, and what is actually the delta between
Yeah.
between SDK releases and understand why, trying to understand externally why developers are
Yeah.
doing new release.
Yeah.
And then of course you have to ask them, right?
Sure. Yeah. That's why we want to do also.
Eventually, but sometimes people tell you one thing, but they do another.
But what we see also is when you use Android Studio or stuff like that, with Flutter et al., then you get nudged into bumping the SDK version like every other day, and it's a pain. So I guess that there are some processes that we could like lower, My students, they're always asking me Java 23 to build, I don't want all the Java versions on my computer, thank you. And Java 7 is sufficient. It's just that their configuration on the computer asked for the latest Java, but it's completely useless. I just modify in the script. So yeah. But you're right about the functionality. Sometimes you really want that feature, and it's going to be the critical finance to FA kind of stuff that are going to ask for that. Yeah.
So, am I waiting for the mic? I'll do it.
We have a question after that. Okay, thanks for the presentation. Are you planning to go also a little bit deeper, for example, at the firmware level? Because, for example, I get a Fairphone, probably a lot of you also have, and Fairphone 3, basically they are stuck with the old version of Android because the Broadcom stopped updating the firmware. And so basically they had to take over the development of this stuff. So it has impacts on software engineering. And also another aspect is that, for example, I kept mine stuck at Android 13 because if I upgrade, basically the biometric stuff will not work because of the downgrading classes. So it's not only software to me, it's also part of hardware, and it's probably difficult to fix. So what are your take on that?
Yeah.
We have written here Adrien Nano, which is a PhD student with Aurélien Tabar, which is part of our team. And they currently have a paper under submission, which just studies exactly that. They have a figure with the Franken kernel. I don't know if you know about that. It's the fact that like Broadcom and stuff like that, they just poop on the mainline Linux and don't modularize the proprietary software. So they are really trying to track down where is the fact of updating a kernel broken, and it's at the very beginning that it gets bad. So yeah, I hope they will be published, and then we can share it with you. But yeah, keep an eye on Eda Nano. It's really her PhD is focused on that, and she was, I think, at maybe not Behave, but an ICT4S in 2023 presenting her PhD topic, and so she's reaching the end. And so yeah, very interesting work, and she's been discussing with post-market OS, Fairphone, Qualcomm, and stuff like that. So yeah, really eager to read the paper.
She was supposed to be here this year, but I don't know if it's the case.
Yeah, she's not coming.
Maybe next year.
So I have a question, but is there any other question? Remotely, if you have any questions, just speak. If you
Yes, I do have a question. I think the first one, which we did not hear remotely, was related, or my question, was it on the data that you presented on the financial game and the results, slide 9? Was it on that, the first question, why you observe the differences between these categories, what is related to finance, what is related to gaming? You mentioned data security, because I was wondering whether the fact that that you can still use a software from an older software for gaming and not for instance, financial purposes was related to the regulatory and data protection changes especially new laws, new requirements to make sure that these stay secure, which might not be the case in the gaming area. Was it this question? Was it your answer?
Yeah, clearly.
No, but
Okay.
we can still rephrase, I guess, like exactly about the fact that there is an issue with the finance, the security really pushes phone replacement very often. So as long as you consider your phone as a valid payment facility, you know, you're going to get stuck in a very new software, big hardware. But yes, nobody cares about having the latest security features on Angry Birds, but we do care about Revolut or your bank account. So yeah.
So it's really about data security. Well, I mean, I was wondering, for instance, if there at some point you have some important changes in regulation, also if you have observe an impact in this kind or in your result, for instance. I mean, like 2020, a big change in regulation, it changes the data from what's came before and what comes after. You know, just a thought on that. And then, given your conclusion, I was wondering, how did you define the 50 years lifespan of the phone? How did you define this objective of 50 years?
That's not us.
It's our colleagues, but you know, it's just the pipe dream. You know, it's the seller point, like it's the commercial pitch. So basically, it's a phone for a life. You know, it's your beloved smartphone. You grew up with it. You want to die with it. You know, you will modify it, pimp it. You know, mod it, anything, replace it completely through the years. You know, but it's your smartphone. You want to keep it. That's the storytelling, the story we are trying to tell.
Yeah.
Okay. And do you do the same, for instance, with other, I mean, the oven, the fridge, the car? I mean, we could do this with everything. So why the phone particularly that much and not other, you know, electronic devices that we have at home? I mean, nothing lasts that long. So it looks like quite a very ambitious objective that people might find it hard to believe in, maybe. You know what I mean?
Actually, the regulation fight is for all electronic device and not only smartphone. But, you know, a smartphone has, as I said in the introduction, a very, very big impact on ecology, human, and so on. And it is our field. So that's quite nice to do research on it.
Yeah, it's really the fact it's really important that this Gaelle, this thing that is so expensive to build, that contains all the metals we know that are not radioactive. You know, we have to start here because an oven. Yes, I have a 50-year-old oven at home. It is very well kept and it's only gas. You know, it works. Like there's really a big gap between the longevity of a smartphone and the one of an oven. So yeah, I think we can work it here because like the stakes is high and the benefits we are going to have through like 1 or 2 years of longevity for a smartphone is huge. So yeah.
And just a curiosity, when you say the lifespan, do you include all the step, for instance, that is taught in circular economy, like repairing, recycling, maybe reair conditioning? Do you include all of these steps in the 50 years?
Okay, I'll take it. I wrote the project recently, so yeah. Why not? But we don't fancy circular economy as a keyword because there's not much circularity here. Mostly, you cannot recycle kind of any metal, you know, like we know how to recycle 8 metals out of the 50, 70 that are inside the smartphone. And it's gold, it's copper, it's, yes, I don't have the English names, but yes. So it's not a lot, you know, we are talking about grams or milligrams per phone. And there are 50, like cadmium, you know, cobalt, for instance, are not going to be recycled. So apart from that, you can, yeah, repurpose it, like repair it, repurpose it maybe, but not for a while. What are you doing with the phones that are lying in your home? Like any of you? Nothing. We are not doing anything with them because they are broken in software. they kind of work. You know, sometimes you have to replace the battery, but they would last 20 years if we could make it work with the software. So yeah, we can take this into account, the circular economy, because it's epsilon. It's kind of non-existent in our viewpoint. We consider that there is a lot of work to do to recycle refurbished phones, and so it's the work of Adrien Nano with the firmware updates and stuff like that. But here we are saying, let's increase the lifespan of this particular smartphone for its primary usage. But why not for the second and the third? You know, if you want the new one, if you have a use case for the new one, then give it to your little sister. I don't know, but yeah, how long is it going to last, this phone?
Okay. Okay. Thank you very much, guys.
Thank you.
Thank you.
Okay. Just one quick question, last one, and then we take maybe a 5-minute breaks after that. So, it's more opening question. Because you're talking about 50 years, we talk about software sustainability and making it last. If we go 50 years in the past, we are in 1975. So if you take a software in 1975 and it works the same as in 50 years ago, is it sustainable? Is it obsolescent? Or, I mean, how do you consider that software without any functional updates, just fixes and security fixes maybe? Is it this is or not? Because what's the difference between let's say Microsoft Word from 2000, let's say, being updated with new functionalities, or a new version of Microsoft built today? How do you find it?
I don't know if I understood quite well the question, but the goal is to continue having updates, but taking into account the fact that you have old hardware to continue using them, but having new features if you want.
So if I take the Apple II, which was released 50 years ago, can we run any modern soft on them? So the idea, if you want some sustainable, like a software sustainable, we need to know what functionality of the software we need to keep it sustained.
I guess you may run Linux. You know,
Apple II in 50 years ago.
Why not? No, not 50 years, you know, but 50 years ago, ICT was born, basically. So it's a bit tough to ask for that, but email as a protocol is not that younger than 50 years. It's like maybe 35 years old, 40. So you could run email. And you know, we are used to Windows, but when you use Linux and you do an update, the software actually runs better after the update. Yeah, it's incredible. But yes, right now you can run some small Linuxes, or you know, some kernels that do POSIX stuff and allow you to run some stuff on really bad hardware that was abandoned 30 years ago. It kind of works. So if you consider that we build the software to sustain old aging devices, you know, as long as we have the mentality throughout the spectrum from hardware to the up software layers, like email, you know, it's an application, it's a user application, but it's built out of a protocol that, you know, we kind of hate because, you know, it's so much legacy, but it's as legacy as building a house, you know. We like having old houses. Why don't we like old protocols?
Email is not encrypted by default, so
it's still
if you want new functionality, if you want new features on an old protocol, you probably would need to update it. And sometimes it might not be possible physically to update a software for 20 years, let's say. Just to...
Okay. But yeah, sometimes you want encrypted emails, but most of the time we just send, you know, physical snail mail that is not encrypted. And this is email. And it's still like the most used and the most necessary protocol that we have in our digital life. You need it to pay your tax, you know. It's the only thing that you really, really need all the time. So it's here to stay, I guess, and unencrypted, because we don't always care about encryption, about new features. There is a bottom of what you need for your digital life. And I guess this hasn't changed, evolved. It could work on crap computers. Yeah, okay.
Think about. So
Thank you.
Thank you all.
thank you.
Data click.
So the first two presentations were mostly technical, as you noticed. So the first two were mostly technical. The next two presentations will be more multidisciplinary, with a social aspect and a psychological aspect.